calculus was added to Newton's equations later by Laplace or someone. Besides, let alone tensor calculus of Einstein. But even at first, it's a very simple way to unify the laws of the cosmos and the laws on Earth. But Newton even got it wrong the first time because he used the wrong measurement. But they just barely invented the telescope at that time. Okay, number 7. He used his theory to explain the reason for the disturbance in the motion of the planet Mercury, the shift in the perihelion of Mercury. There was no known explanation for it before. Yeah, it makes you wonder. Maybe Einstein should have had Nobel Prize just for that, to say that, to explain why a planet actually goes off course a little bit. But I don't think Einstein didn't even mention that. Even Newton said that Newton mentioned that the many body problem was too complicated for him. He only considered 2 bodies at a time, like Sun and Earth, or Earth and Moon. He neglected the effect of the planets and moons upon each other. I used to think there was only 1 moon in our solar system, but I think there's at least 70 moons. And they took away Pluto, and they recently added another planet. Last they discovered like 2,000 planets outside our solar system already. They created a new institute at University of Montreal and at McGill University to study them. Page 8. Number 8. Modification of the degree of curvature of light beam caused when it passes the sun. Observation confirmed the bending of light in accordance with Einstein's theory rather than Newton's theory. This helped confirm his theory to the world. It also made Einstein world famous. Number 9. Calculation of the age of the universe. It's over 10 billion years old, maybe 14 billion. But how? How could it begin? That's one criticism of Einstein. How could the universe begin? Because Aristotle had 6 kinds of cause, and Einstein, like Aristotle, rejected causality of free will and causality of spontaneity. So for Aristotle it was not a problem, because for him the universe was eternal, although even that was a problem unless you had causes vanishing, because you couldn't have an infinite magnitude. But Aristotle, that was not so bad. But for Einstein, he also rejected free will and spontaneity or chance. So then, and yet he said the universe had an age. So how then did it come into existence? Doesn't make any sense. It's not by chance, it's not by free will. The only thing left is efficient cause, material cause, and or formal cause, which is not possible. So in a way, maybe Einstein contradicts himself, and he, without knowing it, he believed in creation of the world by God. So that would prove God exists, and all the miracles are possible. All the miracles are possible. According to Maimonides, the account of the beginning, Genesis, is the most important thing, because it proves all the miracles are possible, and it proves God exists. Number 10, the equivocation of gravity and acceleration. Okay, well, this may be how he came up with general relativity. Number 11, special curvature of length of object in the direction of 90 degrees relative to direction of motion when the object is accelerating, and slowing of time in accelerated frames. Well, this, I don't know if I agree with this. This might be just perception. because you only have one reality out there, but you have many realities in that you have many minds. Each mind in a way is a different reality, although just maybe different in degree, not in kind, because it's just the magnitude is different. Number 12, can reduce the laws of nature to simple algebra. We just don't know how to proceed yet. Well, he said that if quantum mechanics is correct and you only have 4 quantum numbers, then you don't need the very sophisticated quantum mechanics, the very sophisticated tensor calculus equations of general relativity or grand unification theory. But really that's not true, because maybe in orbit, in stable orbits you don't, but even in the cosmos we still need general relativity, especially where we know that you use it there. But you just, when objects are in special orbit, there's more limits on how much they can move, so you can describe them by special orbits. There'll be limited number, they'll be discrete. It's only a limited number of orbits they can take, and this is described by the quantum numbers. And there used to be 3, I don't know if then they added the 4th one. I don't know if Einstein wrote the 4th one, and the 4th one was for spin. But maybe there's more possibilities in the cosmos, because they're usually huge objects. But in a small atom, inside the nucleus, you only have, like, in the different elements, there's a discrete number of neutrons and protons, and only electrons going around in orbit. So there's only a certain discrete number of orbits that are stable. So you can use quantum mechanics, but that doesn't mean that general relativity doesn't apply, except use electricity instead of gravity. And they don't consider the effect of electrons upon each other really in chemistry or physics, because it's too complicated. Just like they don't, that would be the many body problem again. In a way, I don't know if Einstein praised Newton for giving predictive laws, unlike Kepler, who gave the equations of the before that planets going around the sun, which were not really not like Newton's. So in a way, I don't know if the same thing, the equations of Schrödinger and Heisenberg really, and maybe I'm more like Kepler, because they just describe how the object goes around the nucleus. It doesn't really give you predictive laws like Einstein's or Newton's. Anyway, I think it's Dirac only unified quantum mechanics with special relativity, not general relativity. Okay. So I don't think you can reduce it to algebra. Number 13. He resisted accepting the breakdown of the law of causality. He was the first person to consider it among physicists. Quantum mechanics claimed that an object can be sent in the same direction with the same speed, but not end up in the same place. Einstein claimed that God did not play dice with the universe. It is simply because the electron is spinning, so it is so its field affect other objects, which in turn affect it differently, or because it is accelerating question mark. But a world with an element of uncertainty will be more interesting to God than one which is completely determined. For only if there is freedom and spontaneity in the world, then the world will not be known completely even by God. So it will interest God himself even. I think maybe Hume, David Hume might be the first one who questioned the law of causality, and he might have inspired Kant's whole system. He said that Hume woke him up from his dogmatic slumber. Number 14, Doppler shift due to speed also and due to acceleration. It refers to the shift of frequency of a wave which is in relative motion or acceleration to observer. So a light wave can change color, while a sound wave can change its pitch if it is moving or accelerating relative to the observer. Number 15, the new formulations of Maxwell's equations, more complex form. I think Einstein revised the electrodynamic equations of Maxwell, adding a special relativity version of it, for constant speed. I think he also gave a general relativity version of them, where there is acceleration. But I'm not sure. I think they saw that as being artificial. I don't know, something seems funny about Maxwell's equation because they don't consider acceleration. It only talks about speed. And really, general theory is about acceleration theory. And that's when you have a force. You have a force when you have acceleration. I don't know if you can just differentiate the equations of Maxwell to convert velocity, like you have the flow of charge, the current density, and change it into, so it'll be a theory of with force and acceleration, a higher level, because otherwise it's just speed. Speed is more like the law of inertia. Unless it has some, well, it takes time, I think, once you apply a force for it to stabilize the inertia. Number 16, the quantum theory of specific heat. This affects the third law of thermodynamics. The laws of thermodynamics have to do with the nature of heat, question mark. I think one law is that the universe is advancing towards greater randomness, and the other law is that heat flows from hot to cold to find equilibrium. I don't know how that affects pressure, because like if you're on a spaceship and you open a door, the outside is completely, there's no air pressure, so everything will be sucked out into space. Number 17 is contributions to quantum statistics. Also, I think Doreen did something there also, question mark. Anyway, at least add something. I just read somewhere that Einstein influenced Max Born's interpretation of the wave function of Schrödinger in Schrödinger's equation for quantum mechanics, or it's like wave mechanics, which I think it's according to Dirac is equivalent to Heisenberg's matrix mechanics, which came first. But he also helped Heisenberg use matrices in matrix mechanics. Number 18, he was a key figure in new wave mechanics affecting Schrödinger. The latter created a quantum theory with which Dirac proved to be identical to matrix mechanics of Heisenberg. Okay. Number 19, quantum effects may arise from over-constrained field equations of general relativity. Number 20, idea to unify all fields of physics. Today, physicists are trying to unify the gravitational, electromagnetic, weak and strong fields of physics. So I don't know. Now they already have unified the electromagnetic and the weak force, the electro-weak force, and I think the strong weak force. I think the strong fields, I think they call them the color fields now. the weak and strong fields are I think, nuclear forces. They said on the Big Bang Theory, the TV show, the comedy, well, they have like 3 professors of physics and masters of engineering, and actress and neuroscientists and microbiologists. That nothing new was invented in physics since the 1930s. After general relativity and then quantum mechanics, there really maybe computer science, algorithms, and all that. Maybe the new physics, like convert the objects in the world, even stones and all that, into agents. Which is it's not freedom, but it's more sophisticated kind of causality. And Einstein may be the first one to try to unify the forces of physics. He was considering electromagnetism and gravity. Well, no, maybe it goes back to Maxwell, because Maxwell unified gravity and Maxwell unified electric field and magnetic field in his Maxwell and his electromagnetic fields, and he proved the existence of light waves, or EM waves more generally. Now, Newton really, I think, only considered gravity, although he did have a book on optics, which is really the study of light. Okay, page 9. Beaton notes, 2008, on Einstein. This is like from 8 years ago. Number 21. Introducing the tensor calculus to physics, a very complex mathematical apparatus, may have revolutionized physics by allowing for a godlike coordinate-independent analysis of the universe. Adding tensor calculus to physics is a big change. In a way, it also changed, because before, I think, objects were represented by a point, and distances measured from the center of mass from each one, or the center of charge. But Einstein, because of length contraction, time dilation, I think the shape of bodies changed, so even the tensor describes not only the position of the object, but also its distribution of structure. So that could be very important if you believe in special relativity or general relativity, or at least, if not for reality, but for perception. Okay, number 22. Introducing curvilinear, that is, non-Euclidean geometry, non-Euclidean coordinates of Gauss and their generalization by Riemann to higher dimensions. According to Einstein, the mathematician Gauss introduced the method of coordinate systems on the surfaces, and thus made it possible to have a coordinate-independent reference frame. Physics could not use Euclidean geometry, since acceleration is equivalent to gravity, and if consider acceleration of object moving in a circular path, it becomes evident that space is curvilinear. Since special relativity would cause length contraction along the perimeter and the radius will stay the same, so space must become curved. Special relativity will also affect time on perimeter and time at the center, since the object is moving at a perimeter but stationary at center. Well, I think I challenged this view of Einstein, because maybe he used 2 points of view, etc. So I wrote about it somewhere else. Contributions of Einstein. Okay. Number 23. He created a new science of theology or divine science, since he gave equations for the laws of nature, and he did not believe in a personal God nor freedom of choice by anyone. So really he believed that everything was reducible to physics. Even if he saw that his equations were not applicable to quantum level, he felt that this could be rectified. He seemed to have been influenced by Spinoza's identification of God with the universe, pantheism. The Aristotelians did not have the same conception of God, but they also denied the existence of freedom in the world. Maimonides and Einstein emphasized that freedom is needed in order to make religion possible. For Einstein, it was because God is supposed to punish and reward us according to our deed. So you need freedom, otherwise God is punishing himself or rewarding himself. Really, Spinoza's system might be polytheism, not pantheism, in that nature is God. But because he spent so much time trying to prove that human beings are immortal. So in a way, maybe if people are immortal, then we are like gods ourselves. Also, like I said, Aristotle, I don't think Einstein really, Pei said Einstein believed in the God of Spinoza. But this is not so, because Spinoza's God existed forever. But Einstein believed that the universe had a beginning. Unless you see it as I see it, my theory is that Spinoza's theory is really polytheism, that the human beings are gods. So they also have a beginning. But Spinoza felt that they live forever. Okay, number 24. Einstein created a model of scientific investigation for other scientists to emulate. Number 25. Revolutionized science of psychology and philosophy. He forces psychologists to study advanced mathematics in order to understand human perception. They must try to resolve the incredible paradoxes of physics. Yeah, really, most psychologists today, or even doctors, neurologists, psychiatrists, only have a basic understanding of calculus. Sometimes not even that. And there's so many fields of calculus they don't study, and then they forget about it once they go into practice. There's, again, like I said, intermediate, even doctors don't study intermediate calculus, advanced calculus, very advanced calculus, all the programming languages now, that algorithms and methods of artificial intelligence, models of the brain, artificial brain, they apply really now. All these artificial, very complicated mathematical sciences apply to the brain also. So, or even cells of the body. You may use simpler reasoning methods. So they have to teach these to psychologists. And even medicine now, maybe traditional medicine is very prestigious, but maybe it has to be, it's old-fashioned maybe, to introduce all these methods into medicine and choose your doctors differently now. Very hard to get into medicine. But 2-3 years ago, they picked about 189 people out of 2,500 applicants to McGill University Medicine. Let alone a lot of people don't even finish high school, so obviously they're not going to apply to medicine. But it makes you wonder, because doctors are judged on their performance in the end of high school, or here in the end of in SAGET. But I'm not that's a good indicator of how smart you are, because it's not sophisticated. It's mostly memorization. When you go higher up, even in philosophy and physics and mathematics, then it starts to get complicated. But they don't even study that. It's like if the person is the best one on riding a tricycle or a bicycle with training wheels, you don't know if they're going to be actually also the best in riding a bicycle in a race or something, or a regular bicycle later on, which is more sophisticated. So psychology is a new science, 100 years old. I just found recently that Wittgenstein, who they consider the greatest philosopher of the 20th century, him or Heidegger, he said that science of psychology is really impossible. But just a summary, I have to read Wittgenstein. But I think that Nietzsche, in a way, might have found a way to do psychology in terms of the methods of point of view, and especially Husserl, which is maybe one of the greatest and most influential philosophers also of the 20th century. He influenced many thinkers in the 20th century. He's considered the father of phenomenalism. He had ideas of how we can know the world. Although you have to be careful because you might bring back the antimonies of pure reason of Immanuel Kant. Although I think I solved that problem with using different conceptions of time. But I think Husserl also uses different conceptions of time, like one in the world, outside, even another, like 3 different kinds. So I don't know if but I don't know if that's what he used to solve the problem. I don't know if he was aware that it actually brings back the concepts, the antimonies of Kant, just like Einstein brought them back. And there's also Hermann Cohen, the Neo-Kantianism. He believed that you can use the principles of metaphysics as foundation, plus the sciences of physics to know the world. He revised Kant's philosophy, because Kant was very skeptical that any knowledge was possible. I'm not sure, but maybe Horkheimer, who also wrote books with Adorno, I think later in the Frankfurt School, argued a similar thing to Cohen, except that he used the philosophical principles to do sociology by unifying them with social science, just like Cohen suggested for metaphysical physical principles of philosophy, to unify with psychology, to do psychology. Recently I've read some summaries of the 20th century philosophers. That's a very important addition to my system. I didn't think they were important, but they are. At the very least, I think I have to read more about Husserl and Nietzsche and Wittgenstein, maybe Heidegger too. But these summaries were very helpful last a weekend ago and the weekend before that. It was very, very helpful. I'm going to read more summaries first. Number 26, Einstein unified general relativity and electromagnetism, ? But some say he did that in a very artificial way. Even he seems to agree. Number 27, Einstein made physics a 4-dimensional space-time discipline. Well, it was a 4-dimensional before, but Einstein unified space and time. to say have 4 dimensions, we're using the complex using imaginary number I for time dimension. In superstring theory now they had the 10 dimensions, and then Ed Witten, the guy is a very brilliant mathematician, he won the Fields Medal in mathematics. He unified these 5 superstring theories into ones, and he added, now he has 11 dimensions. Like I think I said somewhere, I don't think it's 11 dimensions. I think you still have 4 dimensions, except that it's because of perception. You have distortion of perception in relativity because of the object is moving, and you use light to observe the world. In a way, actually, maybe I even thought maybe you have as many as 18 dimensions, really, because you can have, time might not be one-dimensional, but might be 2 or even 3-dimensional. So you'll have 6 dimensions, and each one of those can be, that goes 6-dimensional space-time. So not like the 4-dimensional space-time of Minkowski that Einstein used. I have 6-dimensional space-time. This might even allow for freedom, because if we have only 1-dimensional time, we might not be able to be free. So you have 6-dimensional space-time. So you might have a perception, distortion of space-time. Might be like, so it might go to 18 dimensions. So it's even worse than string theory. But I know I'm saying it's perception, it's not really out there. Because you have many people, each one has different perception. You can't have many realities.